Tests of differences, t-tests and ANOVAs. The dependent t-test is also known as a matched t, matched pairs t, paired t, dependent samples t, repeated measures t within subject t. For each subject, the dependent variable is measured on two levels of the independent variable. Response time for recognizing words when primed and not primed. Each subject gets both conditions. Or the dependent variable is measured on each member of a uniquely matched pair of subjects representing two levels of the independent variable. Proportion of passives produced by mother and child. Independent and dependent t-tests. These samples are dependent if members of one sample are related to members of the other sample. Unprimed and primed. Independent t-tests, also known as independent samples t, two sample t, independent groups t between subject t. For each subject, dependent variable is measured on only one level of the independent variable. Response time to recognize words, but each subject is in either the primed condition or the unprimed condition. Each subject gets one condition. The proportion of passives is measured, but the subject is either the adult or child. Each subject is in only one group. Independent and dependent t-tests. These samples are independent if members of one sample are unrelated to members of the other sample. So the condition, response time. T-test and ANOVA, when and why. When we want to compare means, we can use a t-test. This test has its limitations. You can compare only two means. Often we would like to compare the means from 3 or more groups. It can be used only with one predictor's independent variable. The ANOVA compares several means. It can be used when you have manipulated more than one independent variable. It is an extension of the regression or the general linear model. So when you're only able to compare two means, you can compute a difference based on subtraction of a didactic operation. You could compute multiple t-tests when the number of levels are greater than 2. 6 t-tests would be needed to compare 4 levels. For example, A minus B, A minus C, A minus D, B minus C, B minus D, C minus D. But multiple t-tests increase the chance of a type 1 error. And experiments often have multiple independent variables. For example, the effects of a placebo, low and high dose on men and women. You need to look for interactions among the independent variables. The solution to generalize the t-test so that can handle any number of levels. So why not use lots of t-tests? If you want to compare several means, why don't we compare the means with t-tests? Because you can't look at several independent variables and because it inflates the type 1 error rate. So here you have 3 different variables. You could say 1 verse 2, 1 verse 3, 2 verse 3, but you have an error.